Hello, ladies and gentlemen. My name is Edward, and let me go ahead and apologize beforehand if I sound a little bit under the weather. But so I'm going to be doing this video a bit differently. So typically, I would have this whole thing kind of edited and refined, and just do like these little update videos. This time around, I'm going to do a long one. Minimum edits, and you're going to be seeing like this whole process. I'm just thinking, what if there's people out there who want to see things done in the background, you know? And like, let's go through like the thought process and the problems I encounter. So on this long video here, I'm going to go ahead and go over the stuff that I've done with this Vtol, alright? And the things that I plan to do with this. You guys tell me what you think. Whether you guys want to see more of what's happening behind the scenes or not. Anywho, let's get to it. So first and foremost, I got lights. Let me turn this on. So, I got myself lights. When the switch is on, all these little guide lights will pop up, and they're associated with, oh gosh, that's loud. I'm sorry. Yeah, some other stuff. So, I have made an artificial horizon, which, to my surprise, is not as hard as you think. Maybe not as accurate as what's going on, like actually the actual horizon, but still not too bad. Got a speed, got an altitude, and I wanted to put a camera because it just looked nice, in my opinion. And then when it gets dark, put that into infrared and use that good stuff. Also, got myself the heaters, cockpit heater, and the cabin, so I can go to the Arctic without dying, which I do want to make such a test. I'm going to slide forward here. Yeah, optimal RPS 55. That's... Oops, sorry for the mic. Okay, so yeah, at 55 is where it rests comfortably. Okay, so what else? Oh, yes, lights. Give me darkness. Alrighty, behold, absolute darkness. We got ourselves nav lights, finally. Ground lights, which are these 4 spotlights on the bottom. Perfect when I come in for a landing. I go whoosh. In case the area needs to be illuminated a little bit, I can do that with you. So huzzah to that. Got myself the cabin lights, which refers to the cabin in here. A nice gentle yellow color, easy on the eyes. And the cockpit lights, just for me. And of course, got these little ducts, entrance and exits. Today, though, here's the plan. This side over here is going to have a map, alright? Later on is going to have some radar functionalities, which I will then use with these buttons here. And then, whatchamacallit? And then over here is going to be... No, wait, no. This was comms. I think. This was to be comms. Yes, and this one's to be the map. Yeah, because I'm trying to balance out color as well. For visual stuff. Anywho, now this is the part that I question whether you guys want to see it or not. But again, you let me know. Okay, so over here, comms. This thing is going to be switching between, I guess this one's going to be for ground crew, constant communication with the ground crew, and this is for anyone else out there, any other vehicles and such, and you can switch from one to the other. I know there's going to be a whole switchbox stuff for that. Over here, though, we're going to use you for the map. Now, one thing I want to add in here, give me a transponder locator. We're gonna use you when the time comes. Let's go ahead and get a map. So let me go grab my blank microcontroller. Boop. There we go. So, what am I going to need? Well, first and foremost, I'm going to need an output of a video. And this is display out. Okay, nice. Oop. No, wait, no. Eh, there. You go there. Now, what to get? Hmm. I suppose I need the basics GPS data. So, I could take a number. No, actually, no. A composite. Here's why. So, yes, there is a thing in here called a GPS sensor. All right, gives you X and Y coordinates of where you are. But that's not the only guy that does that. In fact, let me tell you something. All right. Let me give you a little bit of fun secret here. All right, there are some blocks here that provide so much information, it is ridiculous. All right, all this. All right, so this altitude display that you see here, and the speed, and even the horizontal line, the artificial horizontal line that I've made, all comes from this guy right here. Hold up. Where is he? This. Um, one of these. This one. There you go. The ones with the arrow. This guy is known as a physics block, physics sensor. All right. Look at what this guy brings out. Okay. Look at what comes out. This composite. All right. See, look at that pretty little list right there. Get ready. So not only do we get X position, Y position, which is your distance from the ground, Z position, which is whether you're going north or south. You got the Euler rotation, X, Y, and Z. Linear velocity, X, Y, and Z. All right. Angular velocity and the respective planes. You got absolute linear velocity. That's how I am getting my speed indication. Absolute linear velocity. And then local tilt Z and X for the horizontal, for making my horizontal line. But look right here. So we also have compass heading. So it also acts as a compass as well. So it's a combination of a GPS sensor, compass sensor, and what is it called? Space sensor or something like that. So wait, it's a combination of a GPS sensor, a tilt sensor, a velocity, a speed sensor, and a rotational speed sensor. Did I say tilt sensor already? A compass, all in one block. All in one block. That's really good. Like, holy jeez. That's nuts, man. That is so nuts. So, by technicality, all I really need to do. Well, what are you? Oh, all I really need to do is just extract from here. That makes making this a lot easier. So that means all I need is a composite. It's just physics in. Physics block. Physics sensor in. Now, the GPS functions only work if you put power into that block. So take that in mind. And then from there, I'm going to then use another composite. Okay. This one is specifically panel in. I'm thinking of using a panel to zoom in and out. And now with that said, let me go and put it. Okay. I will put it right here then. Panel. Here we go. Here we go. So instrument 1, instrument 3, 2, you are nothing. 4, you are nothing for now, because we may put something in you later. You're going to be 1, you're going to be 2, and you're going to be arrow button. Both of you shall be arrow buttons. You'll be up, you're going to be down. Zoom in, zoom out. Sometimes I go for an automated system where depending on how fast you go, depends on how much it zooms in and out. But yeah, this is just something like that. But okay, so we got ourselves that, which is good, very good. Of course, let me go and put a battery connection. I got a small battery here to take care of all of the electronics up front and the display in case something crappy happens back here. This will be okay. It is also getting charged from the back. Now, I have it connected to a charger because I don't want it connected to this system back here. Because if I connected this battery to this battery, then they're all one big old system. I specifically just want to isolate these so it doesn't. Alright, do I have everything? I think I have my physics stuff, got the panel there, got I think that's all I really need. Hold on, let me go ahead and plug the thing here in. Oh yes, I also want to apologize beforehand. You will be hearing strange noises from me. It helps me think. I'm a mad scientist. I can't help it. So, what are we going to start with? Control panel in, physics sensor. Yay. Wow. Let me see. You take 17. Okay. Trying to remember some things. We need a right. Composite right. Okay. And we're going to only have one number, but you're going to start at channel 18. Because I think one, no, no, sorry. You start at channel 18. You will not have 18 inputs. That's intentional. So, yeah, here's why. Oh yeah, we need Lua. Here we go. Lua. So, Lua goes over here. Boop. Composite right number and whatnot. It's going to go in here. Physics sensor. You're going to go in here. Now, if you guys are not familiar with composites, I don't blame you. It was a bit of a tricky thing. Sometimes I make my mistakes here and there, but every composite connection. All right, so yeah, if you're new to the composites, let me give you a quick little thing to keep in mind when you want to work with composites because they're really good. It's really, really good. Each composite connection, okay, can carry 32 lanes of information. Okay, what you got to keep in mind is one, who's occupying those lanes? Okay, which ones you got space available? Are you restricting anything? And when you take information through, you got to be careful not to accidentally replace the information you needed. So in this situation, we have the physics sensor. Channels 1 through 17 is being used through here. All right. This one is going to be using just channel 18. So that means this whatever number I put in here is going to only go through channel 18. So then after all this goes through, Lua is going to be taking in information from channels 1 through 18. So what am I going to be doing with this control panel in? I'm going to take a read. It needs to be read on and off. There you go. Give me a second one. Right on. So what's going to be for zoom for down, and what's going to be for up. Right, and your min value is 0.1, max value is 50, increments 0.01, I think. No, just do 0.1. And clamping it. Keep clamping it, keeps things in range. So I think that will do. Also, rate my organization, because I kid you not, I have seen people I've seen people's custom logic stuff, and oh my gosh, it's a mess. Although, if it's not a mess here, it's gonna be a mess in the Lua script. We got a lot of nice information to work with, but we don't need too much. So let's go ahead and clean things up here. The zoom, right? Zoom is equal to input.get number with the 18. Yes. Yay. And let me go to the draw to the list here. I am happy that they have this nice list. It helps you get familiar with their main code of all this display stuff. And you can just go raw dog kind of freaking Lua itself and get into the game, get into the game files if you really want to. I mean, it's a legit little coding platform. You do what you want, just don't break anything. This touchscreen data, I want to get good with this. Like, what does this all really mean? What are you referencing to? It's like, huh? If press rectangle and such, because this is cool stuff. You can make a nice touchscreen. Anywho, map. There you go. Draw a map. Very simple looking, isn't it? Very simple looking. Boop. So we have a thing for zoom. It's channel 18. Right. Now, x is equal to, oopsie, not you. Y is going to be equal to u. Now, I'm trying to remember, which one was it? 1, 2, and 3, but I think I need 2 and 3. So x, 1, and 3. I want to go ahead and put a note. One thing that I'm noticing, a big old sin for those who are coding, you don't label your stuff. Label it. Because you're going to come back to this sometime in the future, and it's going to be hard to make sense of what you were doing. So label axis. Okay, so we got zoom. There you go. We got a map. Let's go ahead and see how nice and sweet and basic this map is. I'm going to turn the switch on here. Should give me a nice little map. Yep, and it is showing where we are. Very good. Look at that. That's nifty, ain't it? Hey, yes. Okay, so we have that, and I think that's really, really nice. Now, I would like to put a single dot of where we are. So I'll go, boop, boop. No, I'm going to make it a line. I'm going to draw 2 lines, and we'll cross over each other. Now, for those of you who are who are touching on how to use displays, displays are measured from 0 to whatever pixel length, all right, width and height, and it starts on the top left corner of the display. Okay, a little odd, but all right, that's just how it is. So we got our cross lines to represent ours where we are in the center, and later on, in fact, let me go add another thing here to make it alpha. You're 150. So we're going to make these semi-transparent lines. Very good. And how you do? There you go. Well, see, it's not bad. So this thing's really filling out excellently. I'm liking that. So, look at that. Clean little script. I guess I'm going to be done with it for now. I do have plans on putting a radar function and adding on to this. But as of right now, I think it'll be just fine. Go over here, go over down here. Okay, slide you in somewhere nice and cozy. Yes, I can. Right over here. Yay. You snug? Yeah, you're snug. Good. Alright, paste you in there. Alright, we got a simple little map, which will become complex later on, because I still have to get familiar with radars. Oh, I just realized something. There was another thing I wanted to do. Hold up. We're not done with the map just yet. Yes, we want to edit the microcontroller, and we want to go to properties and make this and label them. Label these too. These names, label these. So map display. there's another thing I wanted to do. Hop onto the Lewis script. So let me go and put this little section here. I want to make a heading indicator. Okay? I want to do that. And let's see, we'll call it heading. Now, how to calculate the heading? Well, so the heading is, we're going to represent it in 360 degrees. Okay, that's common standard. What's not common standard is how this compass thing works. So let's go ahead and go here and put in compass is equal to input.get number, I think you're 17. Oopsie. Yeah, I think you're the last bit of information needed or provided by the compass heading. It goes from negative 0.05 to positive 0.05 respectively. Negative is the measurements start from north. Negative, though, is to the right, is eastward. Positive is westward. So, yeah. How does one potentially do this here? Let's see. So what's interesting is that, oh boy, we'll do conversion is equal to compass. So we got 180 divided by compass. Okay, to do 360. Do 360 divided by the compass, then we're going to get 180. I think we're going to need an if. All right, let's follow the rotation from 0 to from north, east, south, west. So if compass is less than 0, because we're going to get negative numbers, then what you will do is we're going to get conversion. No, I'm going to be a little more better here. Heading is going to be equal to conversion times -1. Else if compass is greater than 0, then what are you going to do? Heading is going to equal to conversion plus 180. Okay. And then anything else, you just end it. Any issue there? All right, so see, my logic is right. This conversion takes 360 degrees, multiplies it by our compass. Our compass goes from 0 to 0.5. So 0.5 being south, that would be 180 degrees. Does this logic hold up? 360 divided by 0.5? Yes. So everything in between should work okay. Roughly. Yes. Now, if, all right, the compass is less than 0, okay, so if we are going eastward, we're going to get the conversion. Instead of getting a negative number, though, we're going to multiply it by a -1 so it stays positive all the time. And it should be just fine. Now, if we go past south, okay, we're in the positive area, which means anything westward, we take the regular conversion value and whatever the compass is, plus we have to include the 180 degrees. Okay, alrighty. So let's go see. When decimal values when things are measured here, the decimal value is deep. Okay, we're going into the millionths and the millionths and the millionths. No, not really. It's like how many digits in? I don't know, like 20, 30 digits in. It gets very detailed, like silly detailed. So I like to do math.floor. So a thing about math.floor, all right, or this stuff. Sometimes you don't want to do all this. You don't do your rounding before. You do it afterwards. So it's going to be equal to math.floor. Okay, conversion. Okay, let's do the math dot stuff later, afterwards. Here we go. This will do good. Go. How the hell? I'm sorry, but we should not be we should not be reaching the value of 1,000 here. I guess I'll put you here then. Okay. I thought this will be okay. Well, it is higher than 0, which explains why we're getting 180, but holy jeez. How are you? What number are you giving me there? Alright, do me a favor, okay? Give me conversion. I want to see what you're showing me here. In this case, I should be with a positive number here, less than 360. Probably more closer to 180. 960? How the frick are you all the way to 960? Take 160 minus 180. What? You're 960. Okay. Let's put you to 180 divided by all those values. Hold on. If we split 180 to a distance of 1.5 of 0.5. Hmm. 360 degrees is equal to that. No. There's a whole bit of logic I'm thinking of here. I thought the numbers would be okay, but roughly speaking. .480. What in the frick, dude? Hold on. Okay. Conversion. Okay. So we're taking... Okay, each half is going to be 180. I'm only showing the conversion. I'm only showing conversion. That's not right. Compass heading negative 0.5 to negative 5 to the respective composition. Alright, let's step back a little further. Let's step back a little bit more and go put this back to 360. I mean, math-wise, for me, it just makes sense here. No. 180. Because a full 0.5 there, it will be equal to 180. Partial will be equal to that. So yeah, hold on, brain. So one whole full circle will be equal to 180. Any portion of that, you get that portion there. So 180. Okay, I think that's where it has to be. Now, question is conversion. Change you to compass. What does the compass tell me? All right, I'm going down the line, seeing what information is being projected here. Okay. You're showing me 0.37. Okay. Good. So, here we go. Logic-wise. So we're taking the compass, which goes up to max 0.5, which is south, whether it be positive or negative. Right? That is, we're taking on the total 180, we're taking it, we're taking the entire unit of 180 degrees, okay, dividing it into all those sections of 0.5, which is a little bizarre. Okay, right. Uh-huh. So that means max out the 0.5. Is this like inverted? No, we don't divide it. We multiply it. I mean, I was aware that dividing it by a decimal is just going to amplify the number, but I think my logic was like crashing here and there. But no, if we multiply by all that, then won't we end up getting 90 if we go full 180 in the bottom? Right. So that's when this 360 thing, oops, that's 260, 360 thing can come in handy. That was it. I bet you that was it. And what's crazy is I knew that it's going to do an amplifying, dividing by a decimal is going to do an amplification kind of thing. Amplify the number, not really reduce it. But my brain was like, what if you divide that chunk, right, a full 180 chunk, into the chunk of 0.5? Like I was thought of it as objects. Oh wait, it's still showing compass. And it's like, yes. Okay. Sometimes we create ratios. Okay, so in Stormworks, there's plenty of ratios being used. Every set amount of this represents a set amount of that. Okay, that was the kind of brain logic that was being used for this. Math logic, though, math logic says no. If you divide by a decimal or divide by a fraction, pretty much, you're gonna just amplify the number. It's the same as multiplying it. So now I think my whole issue's been resolved because I was actually accepting the fact that it's yep, 314. So let's give this baby a whirl then. The door's open? No, the door's not open. Nice. 3, 4, 5, 6, 40, 50, 6, 5, 4. Yep, we're facing more northward. Okay. Facing northward. Ah, hold on. Whoa. Here we go. 2. Facing north. This should be like 3 something. Interesting. So there's a little bit of math we gotta play with here. 0 is kind of doing its thing there. Ah, okay. Oh, I just remembered. The solar-powered yacht has the answer. I remember that I did the code over there too. And actually it was fine. It did the 360 degrees. Gosh, dang it. Over here, composite-wise, you right here. At night is when you use those nav lights. So, for fair reason, if you're going to be flying at night, then you should be using infrared. There we go. Brilliant, brilliant. And now let's turn on the nav lights. Now we have infrared on. Everything is smooth. Look at this. App. She's enough for me. Alright. I'm liking that. The frick is that? It's an observatory. I'm curious now. Hold on. Smooth, easygoing descent. Oh gosh, never mind. Dang, I went down too hard. Holy jeez, wow. Oh. Can I actually observatory? Oh, that would have been so cool. This thing's really coming together. Alright, so that's the map here, and maybe some other bits there, the infrared bits looking good. Next time, if you guys want to, you let me know, okay? I wouldn't mind showing you guys this here, because this I'm going to make it the comms, and then we'll make a touchscreen system with that, which will then connect these two over here for communications. And then I have to make something with the guns. Yeah. But I think that'll do for now. Thank you guys for watching, and please let me know what you think. Do you guys want these longer videos where I go more in depth of what's happening in the background, or would you prefer the short summary ones? Alright, you can let me know with your likes and your dislikes. Anywho, that's it for now. My name is Edward, and this has been Stormworks.